Hi friends, welcome to Friend for Maths, and in this video we can discuss the question number 1 of exercise 2.2 under the topic the relationship between the zeros and the coefficients of a polynomial. The question is, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Here we have given about 6 quadratic polynomials and we have to find their zeros and have to verify the relationship between that zeros and the coefficients of this polynomial. The first polynomial is x square minus 2x minus 8. To find the zeros of the polynomial, we have to find the factors of that polynomial. To find the factors of the polynomial, first we have to split this middle term as the sum of two terms. And the product of that splitted two terms must be equal to the product of these two terms. That is, here the product of these two terms is x square into minus 8, that is equal to minus 8x square. So we have to take two numbers which is equal to minus 8. That is, here we have to split this minus 2x as the two terms, the sum of two terms, and that two terms must be equal to minus 8x square. So we can take this minus 2x as minus 4x plus 2x, because minus 4x plus 2x is equal to minus 2x, and the product of this minus 4x into 2x is equal to minus 8x square. So we can write this polynomial as x square minus 4x plus 2x minus 8. If you have any doubt in the factorization of this quadratic polynomial, I have uploaded a video about how to factorize a quadratic polynomial. So you can watch that video. I will give the link of that video in this description box of this video. Okay. Now we are going to take x outside from this x square minus 4x. Here we will get then x into x minus 4. Okay. And to make this x minus 4 as the common factor, we have to make this x minus 4 from these two terms. Here, to make x minus 4, we can take 2 outside. When taking 2 outside, we will get 2 into x minus 4. This we get here the x minus 4 as the common factor. Now we can take this x minus 4 outside. We will get x minus 4 into the remaining x plus 2 here. Okay. Thus we get this polynomial as the product of its factors x plus 2 and x minus 4. If these are the factors of this polynomial, when x plus 2 equal to 0 or when x minus 4 equal to 0, the value of this polynomial will be equal to 0. That is, when x plus 2 equal to 0 means when x equal to minus 2, and when x equal to x minus 4 equal to 0 means when x equal to 4. That is, when x equal to minus 2 and when x equal to 4, the value of the polynomial will be equal to 0. So we can say that the zeros of this polynomial are minus 2 and 4. Next, we have to verify the relationship between these zeros and the coefficients of this polynomial. For that, we have the relationship between the zeros of a quadratic polynomial and its coefficients as the sum of its zeros will be equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square, and the product of the zeros will be equal to c by a, where c is the constant term and a is the coefficient of x square. Okay, now we have to verify this relationship, that we are going to find the sum of zeros equal to minus 2 plus 4. Here we get 2. This 2 can be written as minus of minus 2 by 1, because we have minus 2 as the coefficient of x here. So to make this in the form minus of coefficient of x by coefficient of x square, we can write this as minus of minus 2 by 1. That is, here the minus 2 is the coefficient of x and 1 is the coefficient of x square. Thus we get that the sum of the zeros is equal to minus of coefficient of x by coefficient of x square. Okay, the next is the product of the zeros, that is equal to minus 2 into 4. We will get minus 8, and this minus 8 can be written as minus h by 1, because to make this product of zeros equal to in the form constant term by coefficient of x square, because the minus 8 is the constant term here and 1 is the coefficient of x square. Thus we will get that the product of the zeros is equal to constant term by coefficient of x square. Thus we verified the zeros and the coefficient, the relationship between the zeros and the coefficients of the polynomial. Okay, the next polynomial is 4s square minus 4s plus 1, and we can split this minus 4s as minus 2s minus 2s, because the product of this minus 2s into minus 2s we will get 4s square. That is, the 4s square into 1 is 4s square. So the product of these two terms also will be 4s square. So we can write this 4s square minus 4s plus 1 as 4s square minus 2s plus 1. Okay. The next, we are taking 2s outside from this 4s square minus 2s. Okay. Taking 2s outside, we will get 2s into 2s minus 1. Okay. And now we have to make this 2s minus 1 as the common factor. To make this minus 2s plus 1 as the 2s minus 1, we can take minus 1 outside. When taking minus 1 outside, we will get 2s minus 1 here. And now this 2s minus 1 is the common factor. We can take this 2s minus 1 outside. We will get the remaining 2s minus 1. So we get this polynomial as the product of its factors 2s minus 1 and 2s minus 1. Here, when 2s minus 1 equal to 0, the value of this polynomial will be equal to 0. That is, when s equal to 1 by 2. Okay. And here, thus we are getting the two zeros, that is 1 by 2 and 1 by 2. Now we have to verify the relationship between these zeros and its coefficients. We have the sum of the zeros equal to 1 by 2 plus 1 by 2 equal to 1. And this 1 can be written as minus of minus 4, because to make it in the form minus of coefficient of s by coefficient of s square, we can write this 1 as equal to minus of minus 4 dividing by 4, where this minus 4 is the coefficient of s and 4 is the coefficient of s square. Okay. And next is product of the zeros. This product of the zeros is equal to 1 by 2 into 1 by 2, and we will get 1 by 4. Here the 1 is the constant term and 4 is the coefficient of s square. Thus we verified that the product of the zeros is equal to constant term by coefficient of s square. Thus we verified the relationship between the zeros and the coefficients of this polynomial. Okay. And the next one is 6x square minus 3 minus 7x. First we have to write this polynomial in its standard form. The standard form is ax square plus bx plus c. That is, here we have to write it as 6x square minus 7x minus 3. Okay. Now we can split this minus 7x as minus 9x plus 2x. Okay, that is, the product of this 6x square into minus 3 is minus 18x square, and we can write this minus 7x as minus 9x plus 2x. That is, the product of this minus 9x into 2x is also minus 18x square. So this polynomial can be written as 6x square minus 9x plus 2x minus 3. Okay, now we are taking the common 3x outside from this 6x square minus 9x. Taking 3x outside, we will get 3x into 2x minus 3. Plus, we have to make 2x minus 3 as the common. That is, we can take 1 outside. That is 1 into 2x minus 3. Okay. Now this 2x minus 3 is a common factor. Taking this 2x minus 3 outside, we will get the remaining 3x plus 1 as the another factor. And now this polynomial is written as the product of its factors 3x plus 1 and 2x minus 3. That is, when 3x plus 1 equal to 0 and when 2x minus 3 equal to 0, the value of this polynomial will be equal to 0. 3x plus 1 equal to 0 means 3x equal to minus 1, and that is x equal to minus 1 by 3. and 2x minus 3 equal to 0 means when 2x equal to 3, that is when x equal to 3 by 2. That is when x equal to minus 1 by 3 and when x equal to 3 by 2, the value of this polynomial will be equal to 0. So we can say that the zeros of this polynomial are minus 1 by 3 and 3 by 2. Next we can verify the relationship between these zeros and the coefficients of this polynomial. For that, taking the sum of zeros, we will get minus 1 by 3 plus 3 by 2, that is equal to minus 2 plus 9 by 6, that is equal to 7 by 6. And this 7 can be written as minus of minus 7, because we have to make it in the form minus of coefficient of x by coefficient of x square. Here the 6 is coefficient of x square, so we can write this 7 as minus of minus 7, because we have minus 7 as the coefficient of x here. So we will get the sum of the zeros as equal to minus of coefficient of x by coefficient of x square. Next is the product of zeros. This product of zeros can be written as minus 1 by 3 into 3 by 2, and that is equal to minus 1 by 2. And to make it in the form the constant term by coefficient of x square, we can write it as minus 3 by 6. This minus 3 by 6 is also equal to minus 1 by 2. So we can write this minus 1 by 2 as equal to minus 3 by 6, where this minus 3 is the constant term and 6 is the coefficient of x square. Thus we verified that the product of the zeros is equal to the constant term dividing by the coefficient of x square. Thus we verified the relationship between these zeros and the coefficients of this polynomial. Okay, the next one is 4u square plus 8u. Here the constant term is 0. Okay, the coefficient of u is 8 and the coefficient of u square is 4. And from this we can take the 4u outside. Taking 4u outside, we will get 4u into u plus 2. Okay, here the factors are 4u and u plus 2. So when 4u equal to 0 and when u plus 2 equal to 0, the value of this polynomial will be equal to 0. That is, when 4u equal to 0 means when u equal to 0, and when u plus 2 equal to 0 means when u equal to minus 2. Okay, so when u equal to 0 and when u equal to minus 2, the value of this polynomial will be equal to 0. That is, the zeros of this polynomial are 0 and 1 and minus 2. Okay, and now we have to verify the relationship between the zeros and the coefficients of this polynomial. For that, we are taking the sum of the zeros equal to 0 plus minus 2, that is equal to minus 2. This minus 2 can be written as minus of 8 by 4. That is, to make it in the form minus of coefficient of u by coefficient of u square. That is, minus 8 by 4 is also equal to minus 2, and this minus 2 can be written as minus of 8 by 4, because here the 8 is the coefficient of u and 4 is the coefficient of u square. Thus we can verify that the sum of these zeros is equal to minus of coefficient of u by coefficient of u square. Okay, next we can find the product of the zeros. Here the product of the zeros is equal to 0 into minus 2, that is equal to 0. This 0 can be written as, to make it in the form constant term by coefficient of u square, we can written as 0 by 4, because we have the constant term here as 0 and the 4 as the coefficient of u square. So 0 by 4 is also equal to 0. So to make it in the form constant term by coefficient of u square, this 0 can be written as 0 by 4. So we can verify the product of the zeros as equal to constant term by coefficient of u square. Thus we verify the relationship between the zeros and the coefficients of this polynomial. Okay, and the next is t square minus 15. Here the constant term is minus 15 and the term of the x is not there, so the coefficient of x will be 0 and the coefficient of t square is 1 here. And next, the t square minus 15 is in the form a square minus b square. That is, here the 15 can be written as root 15 the square. Every number can be written as its square of its root. Okay, that is, this 15 can be written as the root 15 the square. Okay, now t square minus root 15 the square is in the form a square minus b square. A square minus b square is equal to a plus b into a minus b. Okay, here the a is t and b is root 15. So we can write it as a plus b into a minus b, that is t plus root 15 into t minus root 15. Okay. Now these are the two factors of this t square minus 15. Here we will get when t plus root 15 equal to 0 or when t minus root 15 equal to 0, the value of this polynomial will be equal to 0. That is, when x equal to minus root 15 and when when t equal to minus root 15 and when t equal to root 15, the value of this polynomial will be equal to 0. So we can take the zeros of this polynomial as minus root 15 and root 15. Okay. And now we can find and verify the relationship between these zeros and the coefficients of this polynomial. Taking the sum of the zeros, we will get minus root 15 plus root 15, that is equal to 0. That is, this 0 can be written as minus of 0 by 1. Minus of 0 by 1 is also 0, so we can write this to make in the form minus of coefficient of t by coefficient of t square as minus of 0 by 1, because the 0 is the coefficient of t here and 1 is the coefficient of t square. Next is the product of the zeros. We will get minus of 15 into minus of root 15 into root 50. The root 15 into root 15 is 50 and minus here, so minus 15. This minus 15 can be written as minus 15 by 1, because we to make it in the form constant term by coefficient of t square. Here we have the coefficient of t square as 1, so we can take this minus 15 as minus 15 by 1, that is, the minus 15 is the constant term here. Thus we verified that the product of the zeros is equal to constant term by coefficient of t square, and verified the relationship between the zeros and the coefficients of the polynomial. Okay. And the last one is 3x square minus x minus 4. And this minus 1x as the middle term has to be splitted into the sum of two terms, and we can write this minus 1x as minus 4x plus 3x. That is, the product of these two terms is 3x square into minus 4 is minus 12x square, and we can take this minus 1x as minus 4x plus 3x, and the product of this minus 4x into 3x is also minus 12x square. Okay. And now we can write this polynomial as 3x square minus 4x plus 3x minus 4, and taking x outside from this 3x square minus 4x, we will get x into 3x minus 4, and from this we can make this 3x minus 4 as 1 into 3x minus 4. Okay. Now this 3x minus 4 is the common factor. Taking this outside, we will get 3x minus 4 into the remaining x plus 1. Thus we get this polynomial as the product of its two factors, and the factors are 3x minus 4 and x plus 1. That is, when 3x minus 4 equal to 0 and when x plus 1 equal to 0, the value of this polynomial will be equal to 0. That is, when 3x minus 4 equal to 0 means when 3x equal to 4 or when x equal to 4 by 3, and when x plus 1 equal to 0 means when x equal to minus 1. So when x equal to 4 by 3 and when x equal to minus 1, the value of this polynomial will be equal to 0. So the zeros of this polynomial are 4 by 3 and minus 1. Okay. Now we can verify the relationship between the zeros and the coefficients of this polynomial. For that, we are taking the sum of the zeros, that is equal to 4 by 3 plus minus 1. Here it is 4 minus 3 by 3, we get 1 by 3, and this 1 by 3 can be written as minus of minus 1 by 3. to make it in the form minus of coefficient of x by coefficient of x square, because the coefficient of x here is -1. So we can write this 1 as minus of -1, and this 3 is here the coefficient of x square. Thus we can verify that the sum of the zeros is equal to minus of coefficient of x by coefficient of x square. The next, the product of the zeros is equal to 4 by 3 into -1, that is equal to minus of 4 by 3. That is minus 4 by 3. The -4 is the constant term and 3 is the coefficient of x square. Thus we verified that the product of the zeros is equal to constant term by coefficient of x square. Thus we verified the relationship between the zeros and the coefficients of this polynomial. Okay, that's all for today. If you like this channel, please subscribe the channel and share with your friends. See you in the next video. Till then, take care. Bye.